welcome to Chapter 2, Section 6. Now, we've just done a lot of the arithmetic part of negative numbers. And now the book wants to prep us for rational numbers, breaking numbers up even further. And so what we're going to start with is prime factorization. On our way to reviewing fractions and decimals and stuff, mostly fractions, prime factorization is going to help us out a lot. So please, if this is not already familiar to you, please, let's get a handle on it this time. So a factor are the numbers that you multiply together to get a product. For example, 2 times 3 equals 6. This is the product. These are the factors. Okay? So factors are two numbers you use to multiply together to get an answer. If it's prime, it's a number whose only factors are 1 and itself. For example, 2, the number 2. You can only get the answer 2 from 1 times 2. There aren't any other numbers that you can get in there to equal 2 when you're multiplying. So 2 is a prime number, 3 is a prime number, 5 is a prime number. Does that make sense? But 4 isn't. 4 is what we call a composite number. That's a number that with more than 2 factors. So for 4, you could do 1 times 4. You can also do 2 times 2. So it has factors of 1 and 2 and 4. These are the factors of 4. So it's a composite number. So the question to you is, are these numbers prime? Can you recognize prime numbers right off the bat? So let's think about this. Are there 2 numbers other than 1 and 15 that you can multiply together to make 15? Yes, we can do 3 and 5. So this is not a prime number. How about 7? The only way to get 7 is 1 times 7, so that's a prime. How about 5? Again, 5 is prime. You can only do 1 times 5. 6? No, I just explained how 6 is a composite number. 20. You can do 2 times 10. You can do 4 times 5. So 20 is not a prime number. 31. Now when you start getting up there, you got to start thinking about your multiplication tables, and I don't know. 31 is actually a prime number. 28. Multiplication tables, you know that 28 is 7 times 4. So it's not. What if they get really big like this? Well, then you've got to start remembering your rules. If it's even, you know that 2 goes into it. So the first thing you do is you check to see if it's even. If it's even, it's not prime. Works with 5 and 0 too. If it ends in 5 or it ends in 0, then it's multiplied. Then you can divide it by 5. So that's another rule you can check. And then you don't have to do any math. You can just look at it and say, oh no. What about the number 1? The number 1 doesn't count. They say it's neither prime nor composite, because to be prime, you have to have 2 factors, 1 and itself. Well, this has 1 and 1. It doesn't have 1 and something else. So it doesn't fall into the prime category, and it certainly is not composite. So this is a separate thing that we just call 1. So don't include 1 in your primes. All right. Now, when we're figuring out prime numbers, especially with some larger numbers like this, we want to find all the factors that are in a number. And all those factors have to all be prime numbers. So we're going to keep dividing until all of our answers are prime. And we're going to use what's called a factor tree. Here's what it looks like. We're going to do a little upside down V. And you're going to tell me the 2 numbers that are not 1 that multiply together to make 22. Well, for 22, it's 2 times 11. 2 times 11 is 22. Now, the question is, are we done? Did we get prime numbers? 2, is 2 a prime number? Yes. Is 11 a prime number? Yes, it's also prime, so this is done. We have gotten down to our prime factors, so we're done with 22. So now let's try 42. Now if you know your multiplication tables, 42 is 6 times 7. Now I know that 7's a prime number, so we're done here, but I also know that 6 isn't. So 6 I have to keep going. I'm going to break 6 down now into its components, and it's 2 times 3. 2's a prime, 3's a prime, 7's a prime. So now I know I'm done with 42. What about 50? 50 is 5 times 10. Now 5 is a prime number, so we're done there, but 10 is not, so we have to break 10 down some more. 10 is 2 times 5. Prime number, now I'm done. How about 64? 64 is 8 times 8. Well, 8's not prime. 8 is 4 times 2. Well, 4's not prime. 4 is 2 times 2. So that's a prime, and that's a prime, and that's a prime. So we're done with this half. Now we got to do it over here. 4 times 2, well, that's not. 2 times 2. There we go. Now, once you get your factor trees done, you actually have to tell me what the prime factors are. You can't just show me the tree and say, ta-da! You've got to actually have an answer. So the answer to 22 is 2 times 11. Whoops, 11. The answer to 42, and we want to put them in order, 2 times 3 times 7, so the numbers are getting bigger. The answer to 50 is not 2 times 5 times 5, because 5 times 5 we know how to write with exponents, don't we? The answer to this is actually 2 times 5 squared. That tells me there are 2 5s. And now you're not writing this big number. Now, this might not be a big deal for a number like 50, but wow, does it help us with 64? Because 64, the prime factorization is 2. How many times? 1, 2, 3, 4, 5, 6. It takes 6 2's to get to 64. So our answer is 2 to the 6th power. You good with that? So you're going to try it. You're going to do 20, 36, 25, and 16. You're going to break them into factor trees, and then you're going to break them into the answers with exponents. Push pause, give it a shot, come back. All right. 5 times 4, which is 2 times 2, so it's 2 squared times 5. I'm going to do these quickly, hoping that this video doesn't get too long. So that's 2 squared times 3 squared, because there's 2 of those and 2 of those. 25 is 5 times 5, that's 5 squared. 16 is 4 times 4, which is 2 times 2, and that's 2 times 2, which is 2 to the 4th power. What happens if you did your 16 was 2 times 8? Well, your 8 is 4 times 2, and your 4 is 2 times 2, and look what you end up with. 1, 2, 3, 4. You've still got 4 of them. Doesn't matter what direction you go as long as they truly are factors. You've got 2 numbers that multiply together to get that number. Doesn't matter how, as long as you do it correctly. Okay? All right. That's it. This is practice. You got 4 more. 100, 210, 75, and 48. Make factor trees. Tell me the answers using exponents in order. Okay? Good luck. Stars, hazard signs, questions. See you next time. Take care.